Alright, Crewton Ramone's picking up where we left off with third power and fourth power algebra, third degree, fourth degree, showing it's easy. Also, I think stay tuned, I'll make a video on how to cube, right? How to do cubes. When you have something like this, oh, you should see a relationship. You can actually make a rule about, this is x to the third, and you can do it all at once without having to add and, do it in two steps, where you get, oh look at the relationship between these numbers. And we can see how x plus 1 doesn't 100% work, although it does show the rule. But x plus 2, x plus 3, x plus 4, what are these numbers going to be? Well, what's the relationship between 2 and 3 to get 6? What's the relationship between this to get 12? What's the relationship between these two to get 8? And that's all you do every time. And we'll make a video about it and you can see and practice for yourself. Also worked with negatives, by the way. Let's see, and we're all, like I said, we're heading down the road to where we're going to start making one of these factors negative and see how that works. But in order to see that, you need a password. I know it's a huge financial decision because it's $1, but you need a password to see the negatives. Not everything in life is free. It costs me huge amounts of time and money to learn how to do this. And I'm happy to share huge amounts with you so you can teach your kids and remove some of the pain that these children go through in school when it comes to this kind of algebra. I mean, literally, I've seen kids, in serious distress, crying, and believe me, I've been there, because remember, I failed calculus. I failed the calculus. Caused me quite a few tears when I was a senior in high school. Let's see here. Here is a picture. And see, now little kids can look at this picture and begin to decode the picture with symbols. We're very good at that. Primates are very excellent at decoding. So here you see, well, there's the one side, x squared, 5x, and 6. Oh, look, that's factorable. And this is x plus 1. So now we can see that if I have those two factors, you made the two factors first, right? This is, again, a 12-year-old child, well, about to be 12-year-old child, an 11-year-old kid, a student of mine, that looks at this, and all we're doing is counting the sides. So now he's got the sides. Now he has to tell me the whole rectangle, right? And as he said, oh, I'd rather get division, because in division I get the rectangle in one side. So I have to do most of the work, and all he has to do is give me the other side, right? In this case, he has to do all the work. So we found that the two sides are x squared, 5x, and 6, and one side's x plus 1. You should be able to see it there. You should also be able to see this side of it. And remember, we're just trying a picture of what it looks like. And now we can see, oh, there's x to the third, 6x squared, 11x, and 6. This is one way to factor it. Another factor, of course, could be x plus, what? X plus 2? And another factor could be x plus 3. So we could draw it differently. We could make it, what would it look like if it was x plus 2? Well, we'd have to convert these guys into long x squareds instead of squares. We'd have to make them x to the second powers and put them over here, and take some of these x's and put them over here, and then we'd have to factor this, right, into 2 times 3 instead of, right? So there's 3 different ways to factor this. And like I said, I suggest that you take a little bit of time, if you're watching this or if you're homeschooling, and go factor it the 2 other ways. Because obviously this can be factored into x squared, 5x, and 6. Well, obvious if you've watched, quite a few videos from Crewton Ramone's House of Math, because this is duck soup for little kids. Any little kid can put this together. And I mean 5-year-old kids. I have a video of a 4-year-old building this for the fun of it and counting the sides. And you can see that it's x plus 3 and x plus 2. So by the time they get to be 6, 7, 8, I mean, they literally can see it instantly. They decode it instantly. It doesn't take them time. And so make those factors in this rectangle. Make one side that factor, x plus 3. Make the other side a factor, x plus, and then build another, and then do it again and make it x plus 2, and so on. And see what, because there's more than one way to skin a cat, as they say. This can be factored multiple ways, and this can be drawn multiple ways. All right. And then later on, see, we haven't even got to the point where once we get to that, see, he made it into a division problem because it's easier. He even changed it around so it would be a division problem. You can see the picture right there. That's funny. Anyhow, oh, and then we get into negative numbers. But, well, like I said, oh, there's a quick flash. That's what it looks like. if you want to see more and more descriptions and more problems, you need a password. And that'll be in the advanced algebra section, or perhaps later on you can look for a tab that says third and fourth degree. But anyway, there'll be a lot more about this because I'm already getting quite a bit of feedback that people want to see more. How is it possible that little kids can do this? They're just counting. That's how it's possible. Alright, let's go back. And is there anything I should have covered before this? I don't think so. So, the idea being is that take these guys and draw them, and then decode them, and then play around with them and have fun. We literally took this, and like I said, you see some errors here, but again, the kid is 11. You know, that bracket should have been in here. He didn't close that bracket. He didn't close that bracket. I think because I wrote 3, he wrote 3 instead of knowing that, instead of writing x plus 1 and 2x. But really, it didn't matter for the next part of the lesson under the line because we didn't use this x plus 3. We took x plus 2 and cubed it just for fun. Think about that with an 11-year-old kid. We did it just to see if we could and just to see how it comes out. Drew a picture of it and get a deeper understanding of what these symbols mean and how they relate. Now, once I get that, and older students will be able to see, oh, finding zeros when I'm trying to plot these things, because we can take them and put them on the Cartesian coordinate plane and graph it and see what these functions look like. These guys right here, this will have how many zeros? Well, it's going to have, I'll let you figure that out. How many zeros would it have? Well, the zeros are the same, right? Because it's a cube. So it has 1 0 at -2. And how do we do that? For those of you that are just kind of following along and haven't been into the higher mathematics, quote-unquote higher mathematics, we just set this baby equal to 0. Right? We take this, set it equal to 0, and then find the zeros. And here, 0, if I make that -2, then this whole thing is 0. Because 0 times anything, that's why he's your hero. One of the many reasons is 0. Alright, and then on a problem like this one, there's going to be 3 zeros, right? Because, and I don't have it written out, I wish I had written the factors of this one out, but I'm hoping that you can understand that this is just x plus 3 times x plus 2. So my zeros on this one would be the opposites, right? 1, 0. If I had this equal to 0, well, if x is -1, -1 plus 1 is 0. So that's 0, whatever this is. And then another 0 would be -2, and another 0 would be -3. How easy is that? Well, pretty easy when you can see it, right? But not so easy when you don't see it. Literally, I had a child, a student, a senior at a private school try to convince his mom and me that he was learning, what did he say? He had a learning disability when it came to mathematics. And I've heard this before in other ways where people will say, oh, I'm bad at math, so my kids will probably be bad at math because we have bad math genes. I can assure you that your genes are fine and that you haven't passed along mathematic genes that are defective to your children if you couldn't get math when you were in high school, because any child can learn this, because all we're doing is counting. That's it. All we did, really, if I didn't know anything about multiplication and distributive theory of multiplication and so forth, all I'd have to do is count everything that's here. There's my x to the third. There's my 5 plus 1 x to the second. There's my 11x, and there's my 6. It really is that simple. Go to Crewton Ramone's houseofmath.com for more.